Hello, this video is going to talk about the three different forms of the quadratic equation for quadratic relations uh, and how to change back and forth in between the three different forms. Particularly, we're going to focus on the process of completing the square. So we know that for quadratic relations, we have three different formats that we can write the equation: factored form, standard form, and vertex form. And there are different algebraic processes that we use to change between different forms. So, for example, to go from factored form to standard form, we expand. To go from standard form to factored form, that's the process of factoring. To go from vertex form to standard form is also just the process of expanding. We would expand and simplify the x minus h squared part, multiply the a through all those terms, and collect all like terms. And that would give us standard form. And the process that we're going to focus on today is this process right here, where we change from standard form to vertex form. And that's an algebraic process called completing the square. So that's the process we're going to focus on here. We'll do a few examples. Okay, our first example is to rewrite y equals x squared plus 8x minus 2 in vertex form. So we see that this is an equation of a quadratic relation given in standard form. And because we want to change into vertex form, we're going to use this process of completing the square. So when we complete the square, what we want to do is be able to rewrite these first two terms, so x squared plus 8x, we want to add a third term to that will make that trinomial, x squared plus 8x plus something, a perfect square trinomial. And a perfect square trinomial is one that's in the form a squared plus 2ab plus b squared, or in the form a squared minus 2ab plus b squared. And these will factor to a plus b squared and a minus b squared, respectively. So we want to be able to write this as a trinomial that will factor to something plus something squared or something minus something squared. Okay. So what we do is this. We look at this 8 in front of the x, and we take half of 8. By the way, I'm going to be skipping out some of the explanation or details because I know that you've had some other videos that will go through the detail of why this works. I'm just going to go through the general process here. So we take the 8 and we divide the 8 by 2 and then square it. So we're looking at the coefficient of the x term. So the coefficient of the x term is 8. We take 8, divide by 2, and square it. That gives us 4 squared, which is 16. So this number of 16 here, we are going to add 16. And adding 16 makes this now a perfect square trinomial. And we will be able to factor it in the form a plus b all squared. Okay. However, we can't just randomly add a 16 into this equation because that would change the equation, right? Adding in a 16 makes the equation different. So when we add 16, we also take away 16 at the same time. So that adding 16 and taking away 16, we're really just adding in 0, but we now have this 16 that we can use as part of this perfect square trinomial. Okay, I'm going to bring down this minus 2 here as well because we still have that as part of the equation. So in this step here, we have added 16 and subtracted 16. So really added 0. And we got that 16 by taking half of 8 and squaring that result. Okay? So now what we have here, x squared plus 8x plus 16, is a perfect square trinomial and can be factored as x plus the square root of 16, which is 4, squared. And we can double check that by expanding and simplifying this again, right? So we know that, let's do this off to the side. We know that x plus 4 squared is x plus 4 times x plus 4. And then we get x squared plus 4x plus 4x plus 16, which does in fact give us the x squared plus 8x plus 16 that we had in the previous line. So you can always check by expanding and simplifying. So this factored form comes from the square root of x squared is x, that gives us that first term there. The square root of 16 is 4, that gives us that second term. And the positive sign matches the positive sign of the middle term from above. Okay, so that's the first 3 terms in factored form. We still have a minus 16 and a minus 2. And so we collect like terms there and simplify that too. So we've got y equals x plus 4 all squared minus 18. So by rewriting in vertex form, this gives us some flexibility of what we might be able to do with this equation. We can now identify clearly what the vertex is from this equation. So in this case, we know that the vertex would be -4, -18, because if we start at y equals x squared, this parabola has been shifted 4 units to the left and 18 units down. So we know that this is the vertex. And by writing in vertex form, that also allows us to use transformations to graph this quadratic relation. Okay, so let's do another example. This example, we're going to have a coefficient of x squared that is something other than 1. So in this case, we have a coefficient of x squared that is -2. This means we have a little bit to add to our process of completing the square, but the basis of the process is the same. So when we start this one, we are going to start by removing -2 as a common factor from the first 2 terms that are here. So I'm not going to worry about common factoring from the last term. I'm just going to common factor from the first 2 terms. So if I do that, take out a common factor of -2, I'm left with x squared, and then 12x divided by -2 is -6x. And then I've still got the plus 1 after that. So I common factor that -2 from just the first 2 terms. Now, what's left in the bracket, I'm going to do the same procedure that I did with the last example. So I want to turn this into a perfect square trinomial so that I can factor it as something plus something squared or something minus something squared. So in order to write that as a perfect square trinomial, we take the -6, divide it by 2, and square it. -6 divided by 2 is -3, and -3 squared is 9. So we are going to add 9 and at the same time subtract 9, because that makes sure that we're not changing the equation. We're just adding in 0. But it is changing the way the equation's written so that we can manipulate it algebraically. And we still have a plus 1 outside the bracket here. So now x squared minus 6x plus 9, because we've done this process here of completing that perfect square trinomial, we can factor this as a binomial squared. So again, the binomial, the factored form is going to be the square root of x squared is x. The square root of 9 is 3. And the plus or minus sign in the middle is going to match the middle term here. So that's going to be a minus sign in this case, squared. If we expand and simplify x minus 3 all squared, we will get x squared minus 6x plus 9. We still have a minus 9 inside this bracket as well. So I want to make sure I remember to put that down. Right, the plus 9 was part of the trinomial that we just factored, but the minus 9 was not. So that still has to be there. And then plus 1 outside the bracket. So this isn't quite in vertex form yet. We need to expand this -2 into this bracket. So -2 times x minus 3 all squared. And then -2 times -9 is positive 18. And then finally, we collect these like terms at the end here. So we get y equals -2 times x minus 3 squared plus 19. So again, this allows us to perhaps graph this quadratic relation by using the transformations, because once it's in vertex form, we can clearly see what transformations would have happened from y equals x squared. And it allows us to identify the coordinates of the vertex as well. So in this case, the vertex would be the coordinates 3, 19, because the graph has shifted 3 units to the right and 19 units up from where y equals x squared was.